Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
All right, let's take a look at our M&Ms for 2.1.9. Using an equation map, first off, the idea of the equation map is just to model an equation where you got your expression on the left, you got a series of tiles or a series of, we could say, terms being added together or subtracted, and on the right side of the equation, you've got a series of terms being added or subtracted. And so here is an example where if you have 2x minus 1 minus the sum of negative x plus 3, that could be modeled on the left-hand side. Here's your 2x's plus, I actually don't kind of like how they did that because they said minus 1 instead of plus a negative 1. I do agree with this. You're taking away a negative x and positive 3, but that really should say 2x plus a negative 1. That's how that's shown here. And on the right side, you got 6, 1, 2, 3, 4, 5, 6, and then minus 2x's. So if we wanted to solve this, we could do our legal moves, I suppose, where move this guy across the street, so that becomes 3. Stop it. And let me get a little thinner marker there. So you got your 3x's. Once this guy moves across the street, then these guys move across the street to make that plus 4 negative 1s. And then here, move them across the street, and it becomes, I guess we could still do this. You can still do 6 minus 2x. And now I would probably add 2x's to each side. And I would add 4 to each side. So we end up with a 0 pair there, but 5 x's, and a 0 pair here, but 10. So that means that each one of those x's has to be equal to 2 in order for this entire conglomeration of tiles to be equal to that entire conglomeration of tiles. All right, Ling wants to save $87 for tickets to a rock concert. If she has $23 now and will save $4 per week, how long will it take her to buy the tickets? So this ends up being the model for that situation. This is the amount she's starting with, and she plans on saving $4 for every week, where X represents the number of weeks. So 5D process this. What do you know? What are we working with here? We've essentially got a situation where it looks like this. It's like the amount that she wants to save is equal to 4 times X plus 23, right? Starting amount, and then a growth rate. And X is the variable for the number of weeks, and Y is the variable for the amount of money that she saves over time. But in this case, since we're targeting the $87 amount, that's why we wrote the 87 in for Y. So now we just have to solve for X by taking away 23 from each side, then dividing by 4, and we end up with X equals 16. So if she continues with this process in 16 weeks, she will have saved enough money to buy those $87 tickets. When you want to convince someone that 8x plus 2x minus 3 is equivalent to 8x plus 2x minus 3, you can support your claim with associative property of addition. Now, I would say this. I don't like the fact that they're putting that negative 3 there, or that minus 3. So if we write it as 2x plus a negative 3, then technically now we're adding everything together, and you can move those. And this would still say plus a negative 3. But now you kind of see how you can go back and forth between addition and subtraction to make these properties work. Even though technically they're not supposed to work for subtraction, that's our workaround, is using KFC here so that it becomes plus a negative. So determine if the following statements are true or false. Justify your answer with properties. So are you allowed to rearrange the order of two numbers being multiplied? Yes, you can. That's true. That's commutative property of multiplication. What happens when you add 0 to a number? It stays itself. That's a true statement. That is the identity property of addition. Can you take 3 minus, what is that there for? I don't know why that's there. Go away. Okay, is 3 minus 5 the same as 5 minus 3? No, that is not. You are not allowed to rearrange those if you are subtracting them. You have to be adding. So if you wrote 3 plus a negative 5, is now equal to negative 5 plus 3, that would work. But you got to make sure that minus sign stays attached to the 5. And then whenever you multiply something times 1, it's going to be equal to itself. That's the identity property of multiplication, so that is true. Diamond problems. These two numbers, when multiplied together, give you a product that goes on the top, and when they're added together, give you a sum on the bottom. So here you've got a situation where 4 times something equals negative 12, so you know that something's got to be negative 3, and once you know that's negative 3, then you'll add the 4 to the negative 3 to give you 1. And here, that's a tricky one. This is telling you that you've got two numbers, and when they are multiplied together, give you negative 25, but when they're added, they cancel each other out and give you 0. And since we know that two numbers that add together to give you 0 for an answer have to be opposites of each other, then that makes it a little bit easier to figure out what the two numbers must be. It must be 5 and negative 5. Rosa can buy a 24-ounce bag of ferret food for $1.19, or she can buy a 36-ounce bag for $2.89. Which is the better deal? So to figure out which one is the better deal, you got to find the unit rate. Once you figure out the price per ounce, you'll know which one is the better deal. So this ferret food ends up costing almost 5 cents per ounce, right? 0.049, that would absolutely round up to 5 cents. And $2.89 divided by 36. This one, what happened to my little bar there? Let's put that in. This one ends up being about 8 cents per ounce. So the better deal is going to be the 24-ounce bag. And check the problem. This means, at the end of the chapter, that you should be an expert at evaluating expressions at this point. So you take these values, you plug them into the expressions, and then you use the order of operations to get to your answer. Take a look at each one of these. If you're struggling with those, don't understand where you made a mistake, let me help you. And then there is the website, the online book, has a bank of check point problems just like these that you can work on. We are expecting you to be an expert at these problems. Being an expert generally is considered getting 80% or better. So if you got 5 out of 6 of these correct, or 6 out of 6 of these correct, you're doing fine. You understand it. You probably just made a simple mistake. If you're getting 1 or 2 of them correct, you've got some work to do. This is work that Teloro is going to expect that you know how to do when you arrive next year. So practice every time these types of problems show up in your homework and make your corrections. Okay. So that concludes today's homework, and we are going to start getting into chapter review so we can do our chapter test. So let's head over to that. Take care. Bye.
Hey, feeling good.